Okay, so I will go through an example with you. I will obviously not be answering all the questions, but I will read the background information and kind of guide you more specifically in this video. So it says background. An ecosystem is a community of living organisms and the non-living components of the environment. Energy flows in an ecosystem in one direction through food chains, and a food web is made up of all of the food chains within a community of organisms. Food chains and food webs consist of the producers, or the autotrophs of an ecosystem, the primary consumers, which are the herbivores and omnivores of the ecosystem, the secondary consumers, which are more carnivores and omnivores of the ecosystem, and the top or apex predator. Some ecosystems have complex food webs and some do not. In ecosystems with a complex food web, herbivores and omnivores eat many different types of plants, and the carnivores eat many different types of animals. So here's an example of a complex food web and B, a simple food web. If you notice in the complex food web of food A, there's many, many more arrows kind of going in every direction. Whereas food web B seems more like multiple food chains just kind of combined because they're using the same animals. So, biodiversity refers to the variation in species found within an ecosystem, and it is measured in two different ways. One is species richness, which is the total number of different species in an ecosystem. And number two is relative abundance. This measures how common each species is within the ecosystem. Regions that are home to many different species with a high relative abundance of those different species have high levels of biodiversity. However, regions with only a few different species or that have moderate species richness but low relative abundance, meaning not a lot of several species, have low biodiversity. So notice that the food webs above illustrated have the same amount of species richness. So same kind of like different species named, even though the feeding relationships are different. Some of the feeding relationships illustrated in these two ecosystems, however, may or may not be sustainable over time and may result in a net decrease in biodiversity. So this last paragraph is really what we're investigating. I will not go through these questions because I read the background to you and I answered some of them. So you may need to go back, pause me, or read it for yourself. Now we're going to go in and get started with the lab simulator. So again, you click on this link, you open the tab. Again, this is not the simulator. This will not get you anywhere. You need to click Open Simulator in this right corner. All right, so if you go back to the lab, once you have this open, hopefully you played around with it during the instructional video and you kind of know how it works. We need to do this before we do anything else, is figure out what we are going to change in the simulation. It does state this in the guiding question, so I am not going to tell you what it is. You guys should be able to figure it out by reading. Remember, questions start with how does. Our connecting word is effect, and there's something in between. Dependent variable, you guys should be able to figure out as we go through this. It's what we are measuring, what type of data we're collecting. How are you going to decide which food web has greater biodiversity? Again, I'm not going to answer this for you at the end, or just know what data are you looking at and how does that tell you if there's more or less biodiversity? How will you increase the complexity of your food webs? So we need to figure out right here, how are we going to be able to change and go from a simple food web to a complex one? And if you scroll up, it gives you an example. Remember, example A is complex and example B is simple. And then you need to make your hypothesis. Remember, it is an if-then format. So if our independent variable increases or decreases, then our dependent variable increases or decreases, which you already identified. Okay, so now we're at collecting data. This is what I really wanted to show you and help you understand like what you're kind of doing. So I have set up 3 data tables for you to use. However, you may need to alter these data tables to fit your needs and how you want to run your experiment. Remember, what I'm doing right now is just giving you an example. Please do not use this example as your data because I will be able to know as this, I saved this document as teacher example for lab 11. So please don't use this. You can obviously follow through and like kind of change a few different things and use this as your guide, but do not write the same things that I do. You can add rows, columns, or entire data tables if you need. If you want to do a different data table, if you want to get rid of something, these are totally editable and yours to change. You may not even use all the rows or columns, and that is okay too. Again, do whatever you need to, but you do need to have at least 3 trials in order to make this lab a good scientific lab. Doing just 2 trials doesn't prove anything. You want at least 3. Okay, so our first task is to set up a simple food web. It says be sure to only select the organisms you want in your food web. And remember, you do not need all of them. If you want all of them, be my guest. I'm going to warn you that that is a little bit more difficult and will take a lot more time. You do need more than 2. So I think you even need more than 3. So just keep that in mind. All right, so we're going to set up a simple food web first. So I'm just going to pick, I like this tree, so I'm turning it on by clicking that button. I'm going to have the deer eat this tree. And I think I'm going to use a bunny. I don't really like snails, so I'm going to use a bunny eating this grass. So I don't like this grass, so I'm going to turn it off. So now I only have grass. What is this? Plant A and plant C. So now I'm going to go back to my table, and where it says plant B all right here, this, I'm going to shade it in black because I'm not using this and I don't want to get confused. All right. I'm not using herbivore B, I believe. This one is herbivore B, correct? I'm not using that. So I'm going to shade that one also in black or dark gray because, again, I don't want to get confused. All right, the next level. What do I want? What do I like? I like this squirrel. So I'm probably going to have the squirrel eating the rabbit. I'm not really sure if that happens, but, in our simulation, it'll work. And then I don't know what this is. Maybe like an owl or a vulture or something. Yeah, we'll have it eat plant A. Yeah, let's go with that. All right, so this is my food web. I'm not using the top predator, so then back in my data table here, I'm gonna gray that one out. All right, now my data table is set up and ready to go. It says we're gonna need starting population, but in order to have that, we need to run the simulation. So here I go, I'm gonna push run. All right, so let's go down and see what happened. So I know a lot of these lines are kind of like hidden here, but remember, if you watch the instructional video, you can get rid of those lines. So I'm just going to take a look at plant A and just collect all that data right away. So here it is. So the data we need is the starting population after 20 days, 50 days, 80 days, and the end. So day 0, it would be the starting population. There was 5,000. So I'm going to type in here 5,000. We don't need it to be bolded, so it hopefully will fit in there. It doesn't, that's okay. Then we're gonna go to 20 days. So if you just follow the line, or if you look on the graph on the x-axis, here's about 20 days. If you hover, it should show it. So there's 4, 5, 8, 4. 4, 5, 8, 4. 4, 5, 8, 4. Then we're looking after 50 days. Here's my 50. It's about 4, 3, 4, 2. And then after 80 days, here's 80 at the bottom here. 4272. And then lastly, the ending population after 100 days. I got 4267. I'm not going to go through and do this for every single one. I'll do it for, let's say, omnivore A. And then we'll move on to the next one. So I said I'll do omnivore A. It's a little harder to read, so hopefully this helps you guys out. So day 0, there were 100 of them. 20 days, we have 89. 50 days, there's 93. 80 days, again 93. And our ending population after 100 days, 92. Overall, I would say that the population did go down, not greatly, but it did decrease. All right, so that was my simple food web. I'm just gonna skip over to my complex food web because I think that knowing the difference between the two will help you then find one that is in between of complexity. But here it says, be sure to only select the organisms we used in trial 1. So right away, before you forget, I would just shade these in and be like, nope, didn't use that one, can't use it. Didn't use that one, can't use it. And did not use that one. And do that again with trial 3. Okay, so I want a complex food web. If I'm unsure of what that means, I'm going to go look back up here in the background. And my complex food web is A. And look, I used plant A and plant C. So I'm going to want these two to have more than one arrow coming out of them. So to restart your simulator, you just go to reset. And to get everything like turned on or turn off, you can reset the presets. So this little arrow, you can have the presets back. Okay, so again, I didn't use plant B. I had the bunny eating this. I had the deer eating that. Oh, gotta turn it on first. And the deer eating the tree. And what did I say? This. Oh man, see, I already forgot. Make sure you know what is happening. I believe I had herbivore A. Okay, I got that one. And then I used both omnivores. Okay. I had the squirrel eating the bunny because I remember I said I don't think it actually eats the bunny. And then I had the owl eating plant. Okay, so that was my simple one. Now I need to make this more complex. So again, by having more arrows, it is more complex. So now I can have my squirrel also eat maybe the tree because squirrels climb trees. Maybe the deer also eats that short grass, and the bunny maybe even eats the tree. And then maybe this hawk also eats a bunny. So now this is my more complex situation. There's much more arrows going on. I would maybe take a picture of this, know what you did, because obviously even I forgot what I did. But make sure that you can remember. You could even write this down on like a sheet of paper or whatever you need to remind yourself of kind of what happened. Oh, looks like my bunnies kind of died out over here, and my hawks aren't doing too well. This might not be going so well. Okay. All right, so again, let's just start with what plant did I do first last time? I did plant A. So let's just look at plant A right now. Turn off everything else so that I can see it. Perfect. All right, what do we start off with? 5,000 plants again. Awesome. 20 days. Oh, there's 0. And since it's a flat line, I'm assuming that it died out by day 20. I would go back and double check if you are unsure, but that means that my plant A did not survive. And then I looked at omnivore A, so that will be my next data collection. All right, omnivore A. Ooh, doesn't look good over here either, but we're going to see what happens. At day 0, there was 100 of them. And then after 20 days, whew, there's 59, still going strong. 50 days, there's 6 only, but they're still alive, holding on. 80 days, oh, now they seem to have died out. We got 0. So they did not survive either. And then you continue to do this again with your other animals. So maybe a helpful hint before getting rid of all of this, you could do the reset button where it keeps all of these. And now we want a medium complexity food web. So maybe instead of 3 things eating this, maybe I don't want. So I'm just trying to see the arrows. Okay, maybe I don't want my squirrel eating that tree. And maybe I don't want my vulture to eat the rabbit. But I'm going to have the squirrel eat this plant over here. All right. So that would be like my medium complexity food web. There's not arrows going everywhere, but there are more arrows than the simple one and not as many as the complex one. And then just for fun, see what happens. Oh, this doesn't look so good either. Oh, goodness. Now I only have deer left. All right, so then overall, I would take my data again. I would take data on everything, and then I would go back to my lab. I would fill in my medium complexity food web with all of these, and then I would conclude and decide which one had the most biodiversity at the end. So which one had the most or different, whatever you're collecting, living organisms. And that's how you would do your lab.